Hi boys and girls, welcome to our video lab on thermal conductivity. That's thermal, which is heat, conductivity, which means conduction, the movement of heat through objects that are touching one another. Earlier this week, I showed you a piece of material that we are going to use. It looks like this. And I have my two helpers here with me. I have Caitlin, who actually did this lab in 6th grade, and I have Kara, who's in 3rd grade. And Caitlin and Kara, do either of you remember what this instrument that we're going to use today is called, Kara?
Conductometer.
Conductometer. Right, it's a conductometer. What is about it first?
It has like spokes with all different metals on it.
Yes, if you look closely at this, the different spokes are different colors. They're all made of metal, but different metals. What else do you notice about this?
It has letters in the little circle in the middle.
Right, and what do you think in this metal disc those letters might stand for, Kara?
The different types of metal that these are.
That's exactly right. And there seems to be an A, a B, an S, an N, and a C. So I want you to think for a minute, boys and girls, what metals do you know that begin with those letters? So, Caitlin, do you know any?
The A might be aluminum.
Very good, aluminum. Yep. Kara, do you think you might know one?
Copper.
C for copper. Yep. Caitlin?
B for brass.
Right. Cameraman Cameron, you think you know any?
Nickel. I did a project on nickel.
N for nickel. And then what do you think this S is?
Steel.
It's steel, right? Not silver, but steel. Stainless steel, actually. So, Kara, can you write those down while we get
Yes.
a little bit?
Tell me?
Yep. So it's A for aluminum, B for brass, S for steel, N for nickel, and C for copper. Now, while she writes down those metals to collect data for us, Caitlin, what do you notice that the handle is made out of?
Wood.
Why wood, do you think?
Because like the heat won't travel through it.
Right, that's called, do you remember?
An insulator.
An insulator. It's not a good conductor of thermal energy. It has a low thermal conductivity. Something that's a good conductor would have a high thermal conductivity, and something that's a poor conductor of heat, doesn't let the heat travel through it well, would be an insulator and have a low thermal conductivity.
How do you spell aluminum?
Excellent question. ALUMINUM. So what we're going to do is we're going to light this candle, and Karen, I'm going to pull your hair back here because we don't want your hair getting in the candle.
I don't want my hair to burn.
No.
How?
And then we're going to light this candle, and we're only going to put the center disc, that's made of metal also, in the flame, and we're going to wait and allow the heat to be conducted to the ends, where we're going to place these wax pellets. So these, if you want to zoom in, Cameron, are these are like little discs of wax, and we'll put them on the end. So why would we do that, Caitlin? Why would we put, and I'm going to let you go ahead and get started, why would we put the wax on the end?
Because as they heat up, the wax will melt, and we'll be able to see like the time in which they melted, kind of.
Exactly, METAL. Okay, so the way we're going to do this is we're going to have to collect some sort of quantitative or numerical data. And so, Kara, can you go get your iPad and set a timer for me, please? And Caitlin is carefully putting a wax pellet on the end of each of those metal spokes. And that when the heat is conducted to the end, the wax will melt and fall off. And then we'll write down the time. So, Cameron, can you take a look at this data table that Kara is making?
So
tell her what you have.
metal melting data. A stands for aluminum. B stands for brass. S stands for steel. Nickel. N stands for nickel. And C stands for copper.
And what date are you going to write here, Kara?
I'm going to write the times
I'm going to pass the timer to Kate.
I'm gonna write the times that they melted off the thing, and I'm gonna write which one was first, which one was second, which one was third, which one was fourth, and which one was last.
Okay. Any predictions? Which one do you think, Cameron, you had a prediction before. Which one do you think is going to be the poorest conductor?
I think probably the stainless steel because it's also the handle and the maker of the product wouldn't want your hand to get burnt.
I think that's a great idea because if this got hot and I accidentally grabbed it, so you think that's going to be poor. Caitlin, any idea which one you might think would be the best conductor?
I have a guess.
Think. Maybe not gonna be steel. I think maybe one of the colored ones.
Okay, copper or brass?
Could it be brass because the center looks like it might be brass?
That's good. That's a good.
The center looks like it might be brass, and they'd want the center to.
Yeah.
All right, so I'm going to put this in the center, and we're going to watch the timer. Caitlin's going to start the timer, and then let's keep an eye on and zoom in, Cameron, on the different wax pellets so we can see which one melts fastest. So let's go ahead and get started. Start the timer. Now, as you can see, I'm only letting the flame touch the center. So the only way the ends of the spokes are going to get hot is for the actual metal to conduct the heat, thermal conductivity. So you can see I have the center disc, and I'm waiting to see if any of these are going to melt. And so hopefully now the molecules are moving faster. That's what happens when something gets heated up. The molecules start to move faster. The molecules spread apart a little bit, and the heat travels. Now I can tell you right now.
Oh, we lost one.
It fell off.
Uh-oh. No, it definitely did not melt. Place it on there again. Okay, so yeah, I can tell you right now that the handle is not getting hot. So that is good. That means it's an insulator. If I would touch this piece, go ahead and touch the stainless steel one. I don't feel that getting hot either. No, you can touch it. Be careful. I see a little melting going on, so Cameron, make sure you're zooming in here. Do you see one that's melting, guys?
The copper.
Oh, the copper's completely gone. So what do you think? 1 minute and 11 seconds. 1 minute and 11 seconds. So let's take a look at the rest now. I don't see any melting going on yet, but that was quick. So which one was the best conductor then? Oh, do you see something else, Cameron?
Oh, the aluminum is melting.
Okay, so the aluminum's not quite melted, but close, right?
Yeah.
I think we should count that. Oh,
there
let's
we
do it
go.
then. 1 minute, 39 seconds for the aluminum. So what was the best conductor then, Caitlin?
The copper.
The copper. And the second best conductor?
The aluminum.
So copper had the highest thermal conductivity. Aluminum, the second highest thermal conductivity, ability to let the heat travel up. Do we see another one happening?
Oh, the brass.
The brass didn't quite fall off. We want to be consistent with what we call melted. So we're kind of going, there we go. 2 minutes, 9 seconds for brass. So that's funny because we thought that was going to be the best conductor, didn't we? But not quite. Okay, how about the other two? Still nothing with the stainless steel or the nickel. If you feel this, any heat, I can feel a tiny bit of warmth, but not much.
Yeah.
Again, why did we say that?
Because they don't want it to travel down and hurt you.
Right, it's a good chance that someone could grab this when they're
Yeah.
using the conductometer. So it looks like the stainless steel and the nickel are pretty poor conductors as far as metals go. All metals do conduct heat to a point, but some are obviously much better conductors.
Ooh, the nickel's starting to melt.
Oh, I see the nickel is starting to melt. Can you zoom in on that, Cameron? Looks like it's hanging on a little bit, but it's almost. Did it melt completely?
Yeah, I don't see it.
All right, so 3 minutes and 6 seconds for the nickel.
It looks like the steel is
The
sort
steel
of
is starting to
like
melt. I'm gonna
sliding.
feel this. I can feel it getting a little tiny bit warm,
closer, up here, it's getting hot.
but not quite. So let's see. Our prediction was correct that the stainless steel is the poorest conductor, which is interesting. That's why they made the handle out of that, so that it wouldn't conduct heat to the handle and potentially burn someone. So far we have the copper as the best conductor with the highest thermal conductivity.
Yeah.
Aluminum as the second, Kara.
Yes.
What was third?
The brass.
The brass. So that was a medium conductor of heat. And then we had the nickel, and then the poorest conductor, still hanging on there right now, is the stainless steel. Caitlin, what would you predict how long the stainless steel might take, maybe?
I don't know. It looks like it's sort of starting, so maybe like another like 30 seconds. Or
So maybe close to 5 minutes.
seconds.
Uh-oh, I think it's actually starting.
Yeah, I think it is starting too. Like the part of it is.
I'm guessing it will
I'm
stop
thinking
at 4 minutes.
4:30.
Did it drip off yet, Cameron?
Not yet.
Yeah, close. Oh, I could be right. My new prediction is 5 minutes.
So are we waiting it for it to completely drip off? Because that's what we did
Yeah,
before,
that's what
right?
we did with the other
We
ones.
want to keep it controlled. Might not ever completely drip off.
Let's just call it a day. We know it's
All
the
right,
first
so
one.
let's say 5 minutes and 15 seconds
5 minutes and 15 seconds.
for the steel. And then I'm going to be really careful because I bet all of these spokes are now hot now that they've conducted heat. I'm going to blow out the candle. And as Kara's finishing up her data, I want you to think about a few things. I want you to think about, in this experiment, what was the independent variable? What was the dependent variable? What quantitative data did we collect? What kinds of things could we control? What would our controls be? And now I want you to start thinking about analyzing this data. I want you to open up your class notes section of your OneNote notebook and look for the thermal conductivity lab sheet. And you're going to use this data that Kara just collected. Kara, you want to explain it?
Okay, so metal melting data. So the first one that melted was the copper at 1 minute and 11 seconds. It was first. The second one that melted was the aluminum at 1 minute and 39 seconds. The third one that melted was the brass at 2 minutes and 9 seconds. The fourth one that melted was nickel at 3 minutes and 6 seconds. And the last one that melted was the steel at 5 minutes and, well, about 5 minutes and 15 seconds.
Okay, so boys and girls, that was our thermal conductivity lab. It measured the kind of heat transfer called conduction. And I hope that you are able to answer the questions in your class notes section of OneNote Notebook. And I hope you enjoyed this video lab. I miss you all, and I can't wait to see you in person so we can do labs in our science lab. But I hope that you enjoyed seeing this lab. Have a great day and stay healthy and safe. Bye, guys.